Okay, I'm going to read one of the essays that got me into the University of California Berkeley's Geophysics Ph.D. program. They were competitive to get one of those spots. This is my statement of purpose. Here we go. Statement of purpose. Tanis, Coralee, Leonhardi, by Tanis, Coralee, Leonhardi. Reflecting on my life now, I can see a pattern of interests that ultimately led me to geology, but growing up, I never considered being a geologist. In high school, I wasn't sure what direction I wanted to go in college, so I chose to pursue engineering and environmental science. I knew I had always loved two things, math and nature, so it seemed like the dynamic duo of degrees. As I progressed in my college coursework, I realized that I'd rather understand how our planet works using tools such as math and physics, so I switched to geology and geophysics. The first geologic concept that excited me was that of the Bravais lattice. Using discrete translation operations to describe the atomic structure of a crystal was the ultimate combination of math and physics to describe a product of earth sciences. This interest in using math and physics to describe geological processes was further enhanced by my structural geology class, which used linear algebra and differential equations to explain deformation. It was my structure class that inspired me to return to math and ultimately pursue a minor in math, while my mineralogy class has inspired me to take additional physics classes. Currently, I am working on two thesis projects. The first is a high-temperature experimental petrology thesis with Julia Hammer studying the effects of superheat duration and degree on the kinetics of crystallization. Melt relaxation timescales are estimated to be very short, and yet anecdotal observation suggests that superheating suppresses nucleation. My project seeks to systematically determine the influence of superheating on olivine nucleation kinetics in alkaline rocks. This thesis has helped me learn about research from an experimental standpoint and how much time needs to be dedicated to considering all relevant parameters so that the resultant experiment is relevant in regards to understanding natural phenomena. The second project, a physical volcanology project with Tom Shea, takes a different approach to understanding magmatic processes in eruption dynamics and the transition between effusive and eruptive volcanism. This project emphasizes data collection, correlation, and interpretation rather than an experimental approach. The combination of these two projects has provided me with the opportunity to approach problems using a variety of methods, and I have learned how each of my advisors chooses to tackle the question trying to be answered. Through my experience with these projects in my coursework, I have realized the importance of quantifying geology. Much of geology is qualitative, but what interests me is tackling physical observations and processes and quantifying them. For both of my projects, there is one main theme. How does magma act, and how do magmatic processes conditions result in what we observe physically? In my graduate studies, I would like to pursue fluid dynamics and its applications to volcanic processes through the use of numerical models, experiments, and data collection. In essence, I would like to help quantify volcanic and magmatic processes. Berkeley's graduate program is my first choice for this reason. The graduate program at Berkeley requires interdisciplinary and quantitative research in the realm of geology. Specifically, the work of Michael Manga takes a quantitative approach to understanding natural phenomena that I greatly appreciate. I am particularly interested in some of his work linking textural and field observations, such as flow banding and mafic enclave formation, with volcanic processes through a combination of numerical, computational, and experimental methods. Dr. Manga's work concerning correlations between mud volcano activity and seismicity is appealing because of the use of experiments in testing the feasibility and plausibility of different theories to account for mud volcano responses to seismic activity. This work is of interest to me because it uses a combination of math and physics to help quantify processes that we can observe qualitatively. Ultimately, I believe that I would be a good fit for Berkeley's graduate program in Earth and Planetary Science because of my experiences. The varied coursework I have taken has given me the opportunity to explore other fields, and out of all the subjects I've taken, I am pursuing that which interests me, geology and math. Having worked 40 to 100 hours a week in addition to a full course load and research to pay for college, I have learned that the right challenge is worth working hard for. That is why I will be a productive graduate student. I will work hard and am ready and excited to face the challenges ahead.